Now let us look at how we can sketch the graphs of motion. So we are going to look at distance time graph, and we know for the distance time graph the slope is the speed. So because we are measuring distance in meters against time in seconds, then we also look at displacement time graph. Then for that one, we are measuring displacement against time, and that will give you velocity. The slope of that graph will give us the velocity. Then the velocity time graph, the slope will give us the acceleration. Now let's look at how we can do that with some WASSCE example. Sketch a distance time graph for a particle moving in a straight line with I uniform speed and II variable speed. So for the particle that is moving in a straight line with a uniform speed, this is how the graph will be like. So you can see that it is a straight line because the slope at each point is the same, the speed at each point is the same, it's uniform. Now for the second part, the speed at each point is not uniform, so we are going to get a graph like this because the speed keeps changing. It's not a uniform speed, so this is how the graph will look like. Now let's look at this part. We have a body that starts from rest and travels distances of 120, 300 and 180 meters in successive equal intervals of 12 seconds. During each interval, the graph is uniformly accelerated. So we are talking about uniform acceleration. Calculate the velocity of the body at the end of each successive time interval. Then sketch a velocity time graph for the motion. So doing this will help us to sketch the velocity time graph. So for the first stage, stage 1, we have the object from rest, started from rest, so the initial velocity u will be equal to 0 meters per second. Then we have the distance that is covered to be s equal 120 meters. Then we have the time that it took to be 12 seconds. Now we calculate the acceleration using the formula s equal ut plus half at squared. So we substitute these values to get 120 is equal to 0 times the time, which is 12, plus half a acceleration we don't know yet, so times the time, which is 12 squared. Now let's simplify this to get 120 is equal to 0 plus 72a. So we need to simplify further. We get a to be equal to 120 over 72, and this will simplify to 5 over 3 meters per second squared. So that's the acceleration for this stage. Now we need to calculate the velocity of this stage. So velocity is equal to u plus at. We use this equation, so we know the initial velocity to be 0, then the a is 5 over 3 that we just calculated, times the time, which is 12 seconds. So this will simplify to give us 20 meters per second. So that is the final velocity for this stage of the journey. Now we go to the next stage, which is stage 2. For the stage 2 of the journey, the previous velocity becomes the initial velocity. So we have initial velocity to be equal to 20 meters per second. Then we have the distance covered to be s equal 300 meters 300 meters. Then we have the time, because it says 12 equal time intervals, we have t equal 12 seconds. So we now use the formula s equal ut plus half at squared. So we substitute to get 300 is equal to ut, which is 20 times 12 plus half times a times 12 squared. So we simplify to get 300 is equal to 240 plus 72a. So let's group like terms. We have 300 minus 240. 300 minus 240 is equal to 72a. So this will give you 60 equals 72a. So acceleration will be equal to 60 divided by 72. And when we simplify this, you get 5/6 meters per second squared. Now we need to calculate the velocity of this stage. So we are still at the second stage, stage 2. Velocity, we use v equal u plus at. So v equal u plus at. Substitute to get the u, which is the initial velocity, to be 20 plus a, which is 5/6 that we just calculated, times the time, which is 12. So this will simplify to 10, and this will, the whole thing become 20 plus 10, which is 30 meters per second. That is the velocity of that stage. And then at the end of that stage, that is the velocity, 30 meters. So now let's proceed to the third stage. So stage 3. We know the distance this time is equal to 180 meters. Then we have the velocity, initial velocity, to be 30 meters per second that we had from the previous stage. Then we find our time to be 12 seconds still. So we use the formula again, s equal ut plus half at squared. Then this will be equal to 180 equal ut, which is 30 times 12 plus half times a times 12 squared. So this will give us 180 is equal to 30 times 12 is 360. 360 plus half of 144. So this will give us negative 180. This is over 2. So negative 180 equals 72a. We solve for the acceleration this time. To be equal to acceleration will be equal to negative 180 over 72, and this will simplify to negative 5/2. Now the velocity using u plus at will be equal to 30 plus negative 5/2 times 12. So we simplify to get, so we simplify to get 30 minus 30, which is 0. Therefore the final velocity for the third stage is 0 meters per second. This means that the object came back to rest. 0 meters per second. So we've seen how the graph is going to look like. From the first stage, the graph went up, the slope was up, then it went up again for the second stage, then for the final stage it came back to rest. Hence, this is how the velocity time graph for the motion will look like. So we have 12 successive time intervals, then we have the velocity. The first one is 20 meters per second that we calculated, then the second one is 30 meters per second that we calculated for the second stage. Then we also had the final one to be 0 meters per second. So these were the velocities, and this is the velocity time graph against the velocity against the time. So that is the sketch for the second part of the question. So this is part 2. So we've seen the velocities at each stage. We're asked to calculate the velocity of the body at each stage. So we saw the first one to be 20, then the second one to be 30, then the final one to be 0 meters per second. Now let's proceed to the next example. A car accelerates uniformly from rest until it attains a speed of 40 meters per second in 45 seconds. The car travels at this speed for 20 seconds and it is then brought to rest with uniform retardation in 10 seconds. Sketch the velocity time graph of the motion. Then calculate the distance. So this is the velocity against time axis, and because we were told that the car accelerates uniformly from rest, so we start from 0 meters per second up to 40 meters per second. So this is how it will look like. So the first velocity is, the final velocity for the first journey is 40 meters per second, then for 45 seconds. So this is the 45 seconds. Then we're told that the car travels at this speed for 20 seconds. So continuing from the 40 meters per second, it maintained that for 20 seconds and it was done uniformly. So this is how it will look like. For that part, for the second part of the journey, we start from the 40 meters per second for 20 seconds. So that will end at the 45 plus 20, which is 65 seconds. So the body maintain a constant velocity during this phase of the journey. Now from this stage, that is to the third stage, the object was brought to rest in 10 seconds. In 10 seconds it was brought to rest. So the final velocity over there will be 0 after the 10 seconds. So we add the 10 to the 65 to get the 75, and we move from this 40 to the final velocity, which is 0 meters per second. So this is how the graph will look like. The graph for the motion will look like that. The first part of the question. Now the second one, we are asked to calculate the total distance covered by the car. So we know that will be equal to the area under the graph. Area under this graph. So we know this graph is a trapezoid. This is a trapezoid. So the area under this graph is given by a formula. It will be the sum of the bases. So this is the first base, and we have the second base 2. So we add the bases, half it, and multiply it by the perpendicular height. So area of trapezoid is equal to half times the sum of the bases. So b1 plus b2 times the perpendicular height. So we just have to plug in these values to find the distance covered. So we know the height is 40, the perpendicular height is 40, and we also know that the bases are, the first one is from here to here, so that will be 20. 65 from 65 minus 45 will give you 20. Then the second base is from here to here, so that will be 75. So we multiply it by the height, which is 40. So we need to calculate this, simplify this to get, we know that 20 plus 75 will give you 95. 20 plus 75 will give you 95, and half of 40 will be 20. So you multiply 95 by 20 to get 1900 meters. Therefore, the distance covered by the body is 1900 meters.